Dear students, in this session we are going to discuss about state space representation using phase variables. In the previous video we have discussed about state models, and here that in that case we have represented a system using state variables. Now we are going to represent a system by using phase variables. So state space representation using phase variables. Let us see. Phase variables. What are phase variables? Phase variables are defined as those particular state variables which are obtained from one of the system variables and its derivatives. Usually the variables used in this will be the system output. So the phase variables will be obtained by using the system output, that is y. Then the state variables are derivatives of the output. See here you will be given by differential equations governing the system. So that differential equations will be in terms of the output quantity, that is in the differential equation there will be d square y by dt square, d cube y by dt cube, etc. such type of terms. So that means derivatives of system output will be given. Here output is represented by y. So the derivatives of the output is given. And so we will take the state variables, that is x is the state variable or x dot is the first derivative of x. So the state variables are derivatives of the output. So we will take x in terms of derivatives of y. Okay. The state model using phase variables are easily determined if the system model is in the differential equation form or in the transfer function form. See, in major cases we will be given differential equations or transfer functions. So if we are given by such type of equations, so we will get state model easily by using phase variables. So there are different methods for getting the state model by using the phase variables. We will discuss each one. First we will discuss about method 1. There are other methods such as method 2 and method 3. Here we will discuss about method 1. Okay. First is method 1. Consider the following nth order linear differential equation relating the output y of t to the input u of t of the system. So in this case we have discussed that the input will be in terms of u of t and output will be y of t and state variables are x of t, right? So here we are considering an nth order system, that is it is represented by an nth order linear differential equation. Let us see what is the differential equation, that is represented by dny by dtn, that is represented by yn dot plus a1 yn minus 1 dot. Similarly plus a2 yn minus 2 dot, that is the derivatives. This is the order of the derivative. Here nth order, n minus 1th order, n minus 2th order, like that. Here we will be plus a n minus 1 y dot plus a n into y. That will be equal to b into u. That is the differential equation. And such type of differential equations will be given for you. And in that case you are substituting. Here there is a quantity y will be equal to x. That means state variable equal to one of the output. That is x1 will be equal to y. x2 will be equal to y dot. x3 will be equal to y double dot. Like that we will xn equal to yn minus 1 dot. So this is the form. That means each of the state variable will be equal to output function. Okay. So we can generally write xn dot will be equal to yn dot. Okay. That is x1 dot equal to y dot, x2 dot is equal to y double dot, like that. Okay. So on substituting the state variables in the differential equation governing the system, see this is the state variable x1, x2, etc. So we are substituting instead of y dot, y double dot, we can substitute the values of x. Okay. So we will get, you can instead of y, an into x1. Instead of y dot, an minus 1 into x2. Similarly we can go like this. So finally we will get xn dot here. That will be equal to b into u, which u is the input. So we can isolate this term here. So you will get the terms like this. Okay. You are taking all other terms to the right side of the equal to sign. So from this equation you will get the state equations. Okay. Here you know that the state equation here x1 equal to y, y dot equal to x2. See what is y dot? Here is y, what is y dot? Y dot will be equal to x1 dot. So you can write x1 dot equal to y dot. What is y dot? Y dot is equal to x2. So x1 dot, you can write x1 dot equal to x2. So x1 dot equal to x2 and x2 dot equal to x3. Similarly, xn minus 1 dot equal to xn. Okay. So that is the form that is obtained from here. Since x1 equal to y dot will be equal to x1 dot. So y, instead of y dot you can substitute x1 dot here. Similarly, instead of y double dot you can substitute x2 dot. Like that you will get the different state equations as x1 dot equal to x2, x2 dot equal to x3. Similarly, xn minus 1 dot equal to xn. And xn dot equal to, you have the equation xn dot will be equal to minus an, this equation. Okay, so you can write minus an x1 minus an minus 1 x2 etc. up to plus bu. So these are the state equations of the system. So you will be getting this equation from the previous equation, this equation. Okay, so you got the differential equation governing the system in terms of state variables, right? So you can now form the matrix of this state equations. So first matrix is column matrix containing x1 dot, x2 dot, etc. up to xn dot, that is given here. That will be equal to, you can see in the first term x1 is absent, so instead of that we will put 0, and x2 is there, so you can write 1 here, and all other terms x3, x4, etc. are absent here, so you can put 0 here. Similarly, in the second case x2 dot, here x1 and x2 are missing, so 0, 0 you can put. For x3 you can put 1, that is x 0, 0 here, 1. Similarly, it will go like this. Okay, so it forms a diagonal matrix, right? But finally, when you go to the xn dot case, you will get different quotients, minus an minus 1 etc. up to minus an up to xn term. Okay, so you can write minus an minus 1 etc. up to minus a1, up to minus a1, and that will be multiplied what, x1 x2 etc. up to xn, and that will be plus added with what is the quantity, added with, you have the form, that state variable form, that is equal to x dot will be equal to a into x of t plus b into u of t. Okay, instead of b here it is b, and u, instead of u of t it is u. Okay, so you can write instead of b here there will be this will be a column matrix, so you can substitute this correspond to this xn dot, so you can write all other entries are 0 and last term will be b, and the next matrix will be u. So this will have the form x dot equal to ax plus bu, similar to the first state variable case, and here the matrix A is called system matrix, and that has a special form. It has all the ones in the upper of diagonal, and its last row is containing negative of the coefficients of the original differential equation, and all other elements are 0. This form of matrix A is known as a Bush form or companion form. See, this is called system matrix, this is A matrix. See, x dot is this, A is this is called system matrix, and you can analyze, when you are analyzing this matrix, you can see that it has a diagonal, it constitutes a diagonal matrix except the first column, and at the last you can see that here that last column contains the negative of the coefficients of the differential equation. What is the differential equation? This was the differential equation given to you at first, and so the last matrix contains the negative of the coefficients of this differential equation. Okay, so that type of system matrix is called Bush form or companion form. Similarly, we have another matrix, that is B. Okay, B, what is its entries? All entries are 0 except last entry is B. What is last B? B is given in the question as, see, it is the coefficient of the input. Okay, so we can say that B matrix has all elements 0 except the last element, the output matrix. See, that is a specialty of B. Next, what we require is, we need state space representation, so we need state equations and output equations. So we have to write the output equation y. Here you know that what is y, here you know y equal to x1. So when we are representing it in the matrix form, we can write the equation as y equal to, it has only x1 term, that is 1 is given here, all other entries will be 0, and we can put it as x1, x2 etc. up to xn. So this is the form. So we can write y equal to cx. So this is the phase variable representation corresponding to the differential equations, and the state equation is x dot equal to ax plus bu, and output equation is equal to y equal to c into x, where c is a row matrix whose first entry is equal to 1 and all other entries are x1, x2, x3, etc. up to xn. Okay. So let us do a problem to understand the concept. See, here is a differential equation. You can see d cube y by dt cube plus 6 into d square y by dt square plus 11 into dy by dt plus 6y plus u equal to 0. Give the block diagram representation of the state model. So you are asked to construct a state model, and also you have to draw the block diagram representation. Here the differential equation is given here, and at the differential equation, when you are looking at here, you can see that what is its order is equal to 3. So first of all, here you know that the system of equation is represented in terms of output variable y. So let's just choose y and their derivatives as the state variables. Okay. So the system is governed by third order differential equation. So the number of state variables are 3. So you have to choose 3 state variables, which are x1, x2 and x3. So what will be x1? x1 will be equal to y. That means the state variables will be represented by the output. Okay, so here the output is y. So x1 will be equal to y, and x2 will be equal to dy by dt, and x3 will be equal to d square y by dt square. Okay. Also you can write in x2 will be equal to what? Dy by dt, that is x1 dot. Okay. Similarly x3 is what? D square y by dt square. So that will be equal to x2 dot. Okay. So in terms of x1 will be equal to y, and x2 equal to x1 dot, and x3 equal to x2 dot. That equations you can write. Okay. So what is the next step? You have to form the state equations. So state equation is obtained from this equation, right? And here you can rewrite this equation, this differential equation, in terms of this state variables. Okay. So what is our equation is, we have to put y equal to x1, this is equal to x2, this is equal to x3. Similarly, this term can be expressed as x2 dot, this is equal to x1 dot, right? So from the differential equation you can write what is first term? First term is d cube y by dt cube. So that will be equal to x3 dot. See, this is d cube y by dt cube. What is that? That will be equal to x3 dot, because x3 equal to d square y by dt square. So d cube y by dt cube will be equal to x3 dot. Plus what is the next term? Next term is 6 into d square y by dt square. D square y by dt square is equal to x2 dot. So that will be equal to 6 into x2 dot, or you can write 6 into x3 directly. Okay. First we will represent it in terms of x3. Next, what is the next term? Next term will be equal to 11 into dy by dt. What is dy by dt? That is equal to x2. So 11 into x2 plus. Next, what is the next term? 6 into y. Y is equal to x1. So you can write 6 into x1, and the next term is plus u equal to 0. So the given equations will be represented in terms of the state variables as x3 dot equal to x3 dot plus 6x cube plus 11x2 plus 6x1 plus u equal to 0. You can isolate x3 dot alone. So x3 dot will be equal to this term. Okay. So this is the equation obtained from this equation. Also we have different equations from the previous case, that is x1 equal to y, x2 equal to x1 dot, x3 equal to x2 dot, like that. Okay. So that is written here, that is equal to x1 dot equal to x2, x2 dot equal to x3, and x3 dot, that is what is obtained from this equation. So we have 3 equations since it is a third order system. So we can form the state equations by writing this in the form of a matrix. So left side is a column matrix, that is x1, x2, x3 dot, all dots. That will be equal to, here x1 term is missing, so we can put a 0. Next x2 term 1, and other term is 0. Next x1 and x2 are missing, so we can put 2 zeros, and the third term is equal to 1. Then when we are considering last equation, we have minus 6 instead of x1, minus 11 as the quotient of x2, and minus 6 as the quotient of x3. Next, that is equal to, we have the form. You know that what is the form? Our form is x dot equal to ax plus bu. Ax we have written, that is x here is equal to x1, column matrix x1, x2, x3. Plus next term is b into u. Here b will be equal to, you know that what is b? v is obtained by the quotient of u. Okay, here v will be absent, so 0 0 we can put, and here the quotient of u is -1 into u. So this is the state equations. And here next what we require in order to represent the state model is we require output equations. What is output? Output is y. Okay, what is y? Y will be equal to x1 is the equation. So we can write it in the previous analysis also, y will has got this form, right? So here y will be equal to, what is y equal to x1. So we can represent it in the matrix form as a, instead of y we are writing here it is a third order, so 3 entries will be here. First entry is 1 because y has the form y equal to x1, so first entry equal to 1, and all other x2 and x3 terms are missing, so we put zeros, and column matrix is s1, s2 and x3. So the state equation together with the output equation constitute the state model of the system in terms of phase variables. So this is the state model. So you have to write the state model is, first of all you have to write this matrix, and next you have to write this output equation. Okay, so you are asked also to draw the block diagram representation of the state model. You have to draw the block diagram representation, right? So for drawing the block diagram representation, you have to go to the equation, this equation. Okay, here this is your equation. Finally, when you are substituting the state variable, you will get this equation, that is x3 dot plus 6x cube plus 11x2 plus 6x1 plus u equal to 0. That is your equation, right? So you have to go to that equation, and based on that equation, that was the state equation, based on that equation you have to draw the block diagram. So here you know that first step in drawing the block diagram is that you have to first mark the integrators. What are the integrators here? See, here is a derivative term x3 dot. So in order to get to the x3 here, that is we need x3 from x3 dot. Okay, so first of all you have to draw different integrators. So first integrator, you know that here is x3 dot is a derivative term, so to get the original input you have to integrate it. So you need an integrator, and that integrator will have the input x3 dot, and what will be the output? Output will be x3. So first of all you have to represent that. So you should first draw this integrator, and what is its input? Input is x3 dot and output is x3. You can stop there. Next, where you have to start is, you have the term minus 6 into x3 here. What is its meaning? That means now up to this point you have got x3. Okay, right? But you can see that in that equation minus 6 into x3 means, what is its meaning? Here if this was the equation, x3 dot, that is a derivative term that is obtained by adding all these terms, right? So in that term there is one term which is minus 6x3. So that minus 6x3 comes from where? Here is an x3, so minus x3 will be a feedback path to constitute this x3. But you know that this x3 will be the sum of all these terms. So that means now you can see this term from here. So you can show x3 as feedback in the feedback path, and which is given to a sum, and then that will be given to this x3 dot. See, here you have to note one thing, that here x3 dot is obtained by summing all these terms, but its sign is minus. So you have to add that at the negative terminal of the summer. So now you have got up to this portion. Okay, initially you don't know this summer, because you didn't, there is no need to draw this summer initially. So you can draw this block diagram by simply one adder here and an integrator, and this also, this there is no adder initially. Next, what is the next step? Now you have got up to x3, but you have one thing, that what is x3? x3 is obtained by derivative of x2, right? This is the state equation, right? All other terms of the block diagram is obtained from the state equations. So x3 will be obtained from x2 dash. That means there is a derivative term x2 dash. So corresponding to this x2 dash or x2 dot, there will be an integrator, because in order to get x2 dot, in order to get the x2 signal, what you need is that you have need of an integrator. So you can draw the next integrator near to that x3. So you just draw this integrator, And what is x2 dot? You know that in the integrator, input will be a derivative term and output will be a integrated version of that derivative. So the simple state variable comes at the output. So here you are giving x2 dash at the input of the integrator. So its output will be x2. So x2 dot is equal to x3 means what? Now you have reached up to this point x3. So you can substitute x3 equal to x2 and you can draw the next integrator here and its output will be x2. So now you have reached up to this point, right? So you got x2. So you can again go to this x3 dot equation. You know that x3 dot is obtained by adding this term with minus 11x2. Okay. So that means x3 dot, in order to get the x3 dot, you have to add not only this term but also this term x2 multiplied by 11 and you have to give it to the negative terminal. So here we are drawing a feedback path having scalar quantity value 11 so that you will get 11x2 here, and but you have to give this x3 dot, so you have to add this 11x2 with 6x3 and all this sum should be given to the negative terminal of x3. So now you have reached up to this point, right? So don't stuck at there. You know here x2 you got, but you know from the state equation what is x2? x2 equal to x1 dot. So you can immediately write x2 will be equal to x1 dot. So you know here in the x3 dot equation minus 6x1 is there. So that means you need x1. That means now you have x1 dot here. To get x1 you need an integrator. So based on the number of derivative terms, there will be that much number of integrators will be there. So immediately after the x2 you can draw an integrator because x2 will be equal to x1 dot. In order to get the state variable x1 you have to integrate this x1 dot. So you are writing so you are drawing this integrator here. So now at the output you will get x1, but you know that what is x1? x1 will be equal to output equation y. So you can simply write y equal to x1. But here you can see that when you are giving the integrator here, you will get x1 at this output. And again you have to go to the x3 term. x3 term is constituted by minus 6x1, minus 11x2 and minus 6x3. Up to this term, these two terms you have drawn. Now you have to take a minus 6x1 term. That means x1 is multiplied by a scalar 6 and it is given to the adder with a negative sign. Okay. So here you can draw a scalar quantity 6 so that this x1 is multiplied by 6. So you will get 6x1 here and that will be added to all other quantities in the feedback path and it will be given to the negative terminal of the summer. So it will constitute x3 dot. So now you have got this section. But again you can, when you are going to the x3 dot section, you can see that x3 dot is constituted by not only these three terms but also by this u. Okay. What is u? U in the first, from the initial stage of discussion we have noticed that u is the input. That means it is the external input u. So you can draw the external input as u here. But you know that x3 dot is constituted by the negative u. So you are introducing an scalar minus 1 here and it will be giving minus u and that will be giving to the adder like this. Okay. So now x3 dot is constituted by this minus u, minus 6x3, minus 11x2, minus 6x1. So this equation is satisfied. So these three equations we have incorporated in this block diagram like this. Now up to this section we have drawn. Okay, next what is y equal to output side y equal to x1, that we can simply write y equal to x1 and we can take output from here. So this is the way we are drawing the block diagram representation from the state equations and output equations. So all of you should understand the concept. Once again you can go through the problem, then you will get the clear idea. Thank you.